Okay, now I will give an overview of our Tizen architecture. Here is the software architecture for mobile profile. We have Linux kernel. Based on Linux kernel, we provided the core services like application framework and graphics and input. There is a multimedia service, web service, messaging service, location service, security service, and system service. All those services are based on the native implementation. And on top of core services, we provided the web application development APIs. So basically, Tizen mainly focused on the web application development to third-party developers at this moment. So we provide web APIs, and on top of web API, there will be lots of web application you will develop. I will get into the little bit detail of each core services, core layers of services. There is a kernel and hardware adaptation layer. So there is Linux kernel, of course, and it includes basically SMAC, and there are device drivers to boot up your device. And hardware abstraction layer, it follows the plugin-based architecture. So vendor or manufacturer can keep their modules or engines proprietary with that plugin. Here is telephony plugins, GStreamer plugins, sensor plugins, system plugins. All kind of plugins support that kind of architecture you can use. And we have OpenGL ES and EGL graphics driver. Usually we receive, as a Samsung, we receive those drivers from vendors like Mali chip vendor ARM. They provided this driver and library. For SGX, Imagination will send their library and drivers. So all those kind of stuff will basically based on the DRM, Direct Rendering Manager, based on graphics stack. So we can do some kind of hardware acceleration with OpenGL ES and EGL with this driver stack. You can get a look what kind of core services are provided by Tizen, more detail. We can start with application framework, which is taking care of the application lifecycle management. The yellow color text is actually the name of package or name of Git repository, and some of blue color text is which supports plugin architecture. So application framework also supports application launching, and there should be some installation of packages. So we have SLP package manager here, and base service actually it includes IPC mechanism like Divas or some other libraries here, and database which you will store your data on the, for example, SQLite. It is here, and other essential libraries are there. So I don't explain all of details in this slide. I will explain more later. So you can look what kind of core services are here. In the Tizen application, there is a native application as well as web application. So in this diagram, native application can directly access the core services because the core services basically provide the APIs as a framework. And the web application, actually web is the primary application development environment for Tizen, you know. So we provide the SDK for developing web application, and there would be commercial grade sample application will be open soon with whole source code. So the third-party developer will implement their application based on web standard, and maybe manufacturer or some other vendor, they could provide the native application or some module for native implementation. So what is web application fundamentals here? We follow the W3C HTML5 standard, and more than that, we provide device integrated APIs to utilize the device functionality. And as well, sometimes we'll need to show your application layout like similar to native application. Usually in mobile world, there are lots of widgets. We call it widgets, like such as buttons, lists, or check. That kind of stuff is commonly used in the native application. So we support jQuery mobile-based UI widgets, including the Tizen theme. So, and as well, we extend more widgets for your mobile application. And we have device API, which allows your application access to the platform capability, which supports like Bluetooth access, network, near-field communications, and system information, even application management. They provided by these device APIs. And we will have additional API. It depends on the profile, device profile. So we currently have a mobile profile, but there will be another profile depending on the device. For example, IVI profile. For that case, they will provide additional APIs for device APIs. Here is a chunk of sample code in JavaScript. Actually, it creates the filters here. The first name containing Chris, and the filter would be sent to this contact address book, and you can get the result with this callback function, and you can handle those contact address containing the name Chris. This is just a sample example. I told you Tizen mainly focused on web APIs. We support standard HTML5, and plus we provided Tizen device APIs, and there will be additional miscellaneous device, for example, WebGL defined by Kronos or some other features are there. And you can get plenty of documentation from the site. And here is notice you have to know is Tizen web APIs are not forking W3C APIs, but we provide the implementation as soon as possible. And if there is no standard about some features, then we will provide that APIs with device APIs. So our device APIs basically follow the same rule of W3C HTML5 standard. And there was a talk about web APIs and web application development. So you can download slides and look into what kind of APIs are provided, and maybe the next session will explain about more detail. Okay, let's look into the Tizen core services. I will look into the service by service, and I will enumerate what kind of features provided and what kind of components or modules are there. So first is application framework. The major roles of application framework is launching an application and managing the application lifecycle and handling the system events and it should handle the installing and uninstalling applications, and it should manage the application launch history. So sometimes you can get, you would like to get some information like which applications are recently used by user. And it also supports setting an alarm to launch a specific application at a specific time. So we have two launching application method, which is the explicit, which will use explicit information or implicit information. For explicit information, we will give specific package name to the AUL, which is the application utility library, and AUL actually uses a called Launchpad. This is the demo process to launch your application, and based on the request, it will launch that application based on fork and exec. But we give some optimization to make it fast, make the launch time fast with some pre-link or pre-initialized technology. And regarding implicit launching, we can give information like URI or file names as a MIME type. Then the application Launchpad will launch the appropriate application for using that kind of information. And it allows to launch different type of application. For example, your web application can launch native application and vice versa. And regarding the lifecycle management, the app core is handling that. There are 5 states, application states. When you launch the application, it will be created, and you can pause the application. When you make it background, it will be paused, and sometimes it will be relaunched by the Launchpad, and there should be resume from the post status. So all kind of handling is done by app core, but application should know the time of change of its state. So application usually make callback and add that callback, then app core will call that callback function when your application state changes. So the handling system events is similar way from the application point of view. So application define their callbacks and add that callback for a specific system event. So all are based on the main loop, and the package manager can handle the installation and uninstallation application. So if the application is installed, then the menu screen will show your application's icon, and user can run your application with that icons. And it also provided recently used application history, and there is alarm manager to take care of setting an alarm to launch at specific time. And there was a talk about this Tizen application frame in more detail, so you can download and you can listen that talk from the online. Graphics and input part, we have Enlightenment Foundation libraries, which is the core part of graphics and related stuffs. There is a rich widget set, which supports multiple themes, and basically all those widgets are scalable, so you could give scale factor as a environment variable, then your application suddenly scale down or up based on that value. So this widget is in the elementary, which is the part of elementary Enlightenment Foundation libraries. And the Enlightenment Foundation's core graphics is EVAS. EVAS is retained mode graphics system engine. So it can retain all the objects in the canvas, and it draws very efficiently with its software algorithm. As well, you can accelerate that rendering with OpenGL hardware. So the EVAS actually provided a plugin-based backend like software backend and OpenGL ES hardware backend. All other backends are supported by EVAS itself. And we have talked about overview of graphics and input by me, actually. And there was another talk. There was another talk about Tizen core EVAS by Carson Heitzler. We call him usually Raster or Rasterman. He's the founder of the Enlightenment Foundation libraries. And so you can download the slides and all kind of talk you can listen from online. And as a Windows system, we provided the X11. So all of your applications should receive your window to display something on the screen. So, and then you should use your application directly or indirectly use the Enlightenment Foundation library inside the window. So Windows system support like that. And we have 3D graphics library, OpenGL ES and EGL. We support OpenGL ES 1.1 as well as 2.0, and OpenGL ES EGL 1.4 is supported. And we have font library, FreeType 2, and the font config is used for configuration your fonts on the device. And we have input service framework, which is based on SCIM open source project. But SCIM is basically support the desktop environment, so it doesn't support the touch-based virtual keyboard, something like that. As well, we added more features as a plugin architecture. So vendors or manufacturers can provide their own proprietary engines or modules or user interface with this plugin architecture. And also we provide voice framework. So it supports speech to text and text to speech. It also supports the plugin-based architecture. So you can, if vendor or manufacturer also want to keep their engines or modules proprietary, then you can use that architecture. So I will show some advanced feature of graphics here. So basically, the round blur white rectangle means process. So there is a X server here. So every application, there is one, two, actually, this is also client. There is a 3 client application, and this application is trying to render the video on top of a UI object. So we have emotion, which supports rendering the video contents on the UI object. Then you can transform this rendering result on based on the EVAS. So the transformed result will be on your window. Of course, we can provide the full screen overlay window playing of video contents. All those applications contents will be rendered on the. I lost my pointer. On the textures here, and the rendering result, window rendering result, will be composited by Composite Window Manager E17, which is the Enlightenment Window Manager. So actually, Enlightenment Foundation library is used for implementing the composite window manager called Enlightenment. And Enlightenment also uses EFL for compositing the window back buffers here. So using these features, we can render our video, playing our videos on top of GUI objects. So you can transform the video contents while playing at the same time, like this. So this is based on the hardware spec is based on the Galaxy S2, the same look, and it supports multi-touch, and you can transform 3D. The transformation is done by Avast, and the video playing is the GStreamer taking care of this video playing. Regarding web services, we provide best web experience with web browsers as well as packaged web applications. So, thank you. So, to support a common interface with web-based application, we more focusing on the functionality. So Mr. Nakata, actually, he showed a ring mark, and actually Tizen shows best ring mark score at this moment for the HTML5 spec implementation. And we did a lot of performance optimization with WebKit engines. Actually, major performance optimization was done here, and we also optimized the JavaScript engine. And so regarding UI responsiveness and the 2D, 3D acceleration, 2D canvas is optimized, and 3D WebGL is also optimized with hardware acceleration, and JS engine is also optimized. And we keep the standard compliance for W3C standard. And Tizen device API is support for more device feature accessibility. And jQuery mobile-based Tizen web UI framework is supported, and you can use the pre-existing widget for describing of your application's layout. And the core components for this web service, it would be WebKit and Web Runtime. So WebKit, we call it WebView. Actually, inside WebKit, there is the platform port. We use EFL, so there is a WebKit EFL port. And based on the WebView, we support Web Runtime. So web application, your packaged web application should run on this Web Runtime. So due to supporting the packaged application, we should install or uninstall that application. So installer core take care of that kind of features, and Runtime core supports the web application lifecycle management. And we have Tizen Web API plugins, which is a safe proxy between the Tizen API and JavaScript core. And we have policy for security. So security cores take care of that security policy. Multimedia service is all about playback of audio and video contents, whether it is stored in local storage or via network streaming. And you can capture pictures and recording audio and video. Those are basically multimedia basic features. And for game application, it supports 3D audio sound with OpenAL. And if your device has radio, then it supports handling radio features like scanning the broadcast channels and pick one of them and play back that channel. And we have audio policy, which take care of the collision between multiple audios play. In mobile environment, the specific scenario actually, you can get a call while you are listening to music. For that case, the device should reduce the level of sound of the music playing and start the bell sound, right? The kind of collision should be handled by the platform. So multimedia service also handling that features, that scenarios. And usually media contents include its metadata inside itself. So the multimedia service also support extracting and displaying that information. And it supports playing high quality video up to Full HD 1080p resolutions. Of course, it uses hardware codec, and there is optimization along the pipeline with GStreamer. And we have support various kind of multimedia streaming like HTTP, RTP, RTSP. And we also support HTML5 video tag so that your application, web application, embed the video playback. And there is a high quality camera supports, and you can take a picture with various modes like single shot mode, continuous shot mode, and panorama mode is supported. So the key components here, the GStreamer, Audio Session Manager, Pulse Audio, MFC, and Media Content Service, Audio I/O, all those are for multimedia services. GStreamer is famous open source, and it manages the pipeline of playback when you are play audio or audio file or audio streaming. GStreamer take care of the pipeline for playing your audio. Video is same, and it also support recording, streaming, and editing even. And Audio Session Manager is for taking care of the collision, as I told you. And Pulse Audio, which supports mixing multiple audio streams in software. And we support various support of codec with MFC, multiple format codec. And Media Content Service handles the media file, so you can manage your media file information with database, and you can extract some thumbnails from images or videos. It handles that kind of feature. And Audio I/O support accessing raw audio buffer to manipulate it. So your application want to handle raw audio data, you can use these components. Location service provides hybrid position information from GPS from satellite, and SPS from sensors, and WPS from Wi-Fi access point. So this kind of position information is handled by location-based service. And there is a map service, geocode, which is taking care of the looking for the position from the address, or vice versa. You can give address, then you can give the geographic information. And the POI service also supported, and routing service, find the route service is also supported by map service. And the key components here, basically library, API library for the client application, and there is a provider for supporting the API. So the provider has implementation of GeoClue library API. So location services provide these features. And we have talked about Tizen location. So you can download the slides and look into the details. And system services, it handles the system monitoring and event functionality. So there is four managers: system manager, sensor manager, device manager, and power manager. So system manager runs as a daemon process, and it can monitor device activity when you plug in USB device or MMC card and chargers or ear jack. Then the system manager will send an event to the to your applications. And if there is a battery level change, you can get that kind of event with your application. And sensor manager, which is handling sensor device, maybe mobile device is very integrated with sensors. Lots of sensors are included one single device, and more sensors added. So we need provide the sensor kind of handling manager here. And device manager, which is supports setting and getting device values such as brightness of LCD, and power manager, which is handling about power management. So application can an event if there is a power changes or something like that. And connectivity service provides cellular and Wi-Fi connections and Bluetooth, tethering, NFC, and Wi-Fi. So the cellular and Wi-Fi connection supports always on internet connection based on cellular 3G or Wi-Fi, and the conman manages this kind of connections. And it also supports managing statistics of your usage through the network. And BlueG, we have provided plentiful of BlueG profile, OPP, A to DP, and RF communication, and hand-free profile, and some health device profile we have supported. And it also basic functionality for Bluetooth, like discovering, bonding, exchanging data with remote devices. And tethering, we provide 3 types of tethering through USB, Bluetooth, and Wi-Fi. And regarding NFC, we have NFC manager to handle the NFC plugins, or also it supports plugin architecture. And it also supports P2P, controlling NDEF tag, and car emulator support. Wi-Fi, usually these features are very general features: scanning and connecting to access point and connecting hidden access points. Those are very basic features for Wi-Fi service. And we have telephony services here. So it consists of cellular functionality for communicating with modem. So there is a T-API, telephony API, which is for applications. And the T-API called to ask a question, ask a request to the telephony server, and telephony server should support multiple type of modem. So it supports plugin architecture basically, and it supports 3GPP and CDMA as a plugin. So those are telephony adaptation layer. Personal information management service. We provide contact, calendar, account, and sync services. And sync services based on the plugin architecture. And you can access, your application can access the contact information and calendar information from the device database. And we also support vCard 3.0 spec and vCalendar 1.0 spec respectively. Messaging service, we provide SMS, MMS, and email. So all those kind of service basically from one application each. So SMS is for SMS application. The MMS also from the application MMS. And email also is an application. But there are common usage from other application to access this information. So we provide this functionality as a service, and SMS, MMS, email, and those are client-server-based handling. So your application should use client API to access this functionality. And the server, message server, will take care of your service. Security, which provides the certificate management and verifying that certificate with verification path, and it provides secure storage for confidential data, and user access control management with handled by security services. And we provide the cryptography libraries and SSL, which is fully open source. And our security model, there is no root permission application, and no privilege escalation. So it's totally sandboxed by SMAC, and service daemons will make use of SMAC and enforce access control in server side. So there is a security framework overview at the Tizen conference, so you can look into more details in